today we're going to give the topic about kidneys and osmoregulation. If you remember the last class, we talked about everything that happened in our system and that help us to get rid of wastes. These wastes come in form of urea. Do you know anything else that can be a waste in our body? Do you know what is a kidney or what is its function? Do you know what osmoregulation means, or do you have an idea of what can refer to? Well, thank you for answering the questions. So we're going to follow up with the presentation.
Well, first of all, if you got it right, well, you might as well know that the kidneys, like the function of the kidneys is to get rid of the wastes through the form of urine. But before we see the way that this functions in the human body, we can see that there is also this thing called the Malpighian tubule system. And the Malpighian tubule system is present in the organisms that have a open blood system, like for example insects. So yes, in the Malpighian tubule system, insects have a liquid called lymph. And the lymph is what carries the toxic wastes. In this case, in the case of insects, the toxic wastes are present in the form of uric acid. So, as you can see, here is where the feces of the insects all bundle up. And here, this blank space is the lymph. So, the uric acid will pass through these tubules, these Malpighian tubules, through osmosis. And the Malpighian tubules will deposit the uric acid, which are the wastes, into the guts of the insect. And this way is that the feces, that the uric acid will be disposed through the feces of the insect.
Okay.
Now you are going to see that was the way that the kidneys, like the same that's in the kidney's body in the insects, works. And this is the kidney, and this, of course, is present in the human body.
The human body, yes. Thank you, Alexander. Okay, we can see here a kidney. If you can recall about the kidney, that is an essential organ to our system to help us get rid of waste. Okay, here is the cortex, the outer shell of the kidney. Then we can see the medulla. The medulla, there is the inner part of the kidney. After that, this is the medulla. This is the pelvis of the kidney, where there is a tube where the wastes come out from the kidney. The wastes are already clean, And okay, here's the renal artery and the renal vein. And the ureter. And the ureter goes to the apex. The next slide is about the parts of the nephron.
Well, the parts of the nephron. First of all, we should know that the nephron is located between the medulla and the cortex of the kidney, which are parts that you already saw with Miss Silvana. And yes, the nephrons are placed between the medulla and the cortex. And we have about 1 million nephrons in each kidney, and as you might know, we have 2 kidneys, so we have about 2 million nephrons in total. So yes, the order in which urea passes through the kidney is, first of all, the blood. The urea is present in the blood. So the blood will come to the kidney through the renal artery. And then it will pass through the glomerulus, and the glomerulus happens the process of the ultrafiltration. And then what passes through the glomerulus is then captured by the Bowman's capsule. And from the Bowman's capsule, it goes to proximal convoluted tubule, then to the lobe of Henle and the distal convoluted tubule, and then finally to the collecting duct up to the ureter in order to the wastes to come out as urine.
Okay, in the next slides, we're going to see how the urea is created, because the nephrons function is to keep all those molecules that are essential to our body and filtrate them, right? And get rid of the waste.
Yes, so we will see the path of the urea. But first of all, this is the structure of a glomerulus, and as I already mentioned, ultrafiltration takes place in the glomerulus, and the blood from the renal artery, as you can see, comes through the afferent arteriole, which opens the path through the glomerulus. And as you can see, this is kind of a labyrinth, and in the labyrinth, we also have a lot of mitochondria. The mitochondria is presently there in order for it to supply ATP, which is energy, in order to reabsorb a lot of the components that will make up the glomerular filtrate. And what doesn't pass through the mesh-like structure of the labyrinth of the glomerulus goes out as the efferent arteriole. So yes, and here what you can see surrounding the glomerulus is the Bowman's capsule. And this pathway that all that came out from the labyrinth of the glomerulus will now be called glomerular filtrate. So the glomerular filtrate will be captured by the Bowman's capsule and will take it up to the proximal convoluted tubule.
Yes, and the molecules pass through the fenestrations of the
Yes, through the fenestrations, because remember that the labyrinth is like a mesh, and this mesh is used to filtrate all of the molecules that will make up the glomerular filtrate, and these molecules are some glucose, or water, or urea, some salt ions, and yes, but those that do not pass through the glomerular filtrate up to the Bowman's capsule and go back through the efferent arteriole are proteins, are blood cells, and big molecules of glucose. Okay, so yes. Do you have any questions? No? Okay. Well, now, the structure of the proximal convoluted tubule. This is the cross-section of the proximal convoluted tubule, and as you might see, this, like circles, right here, those are mitochondria, and in the same way as the glomerulus, the mitochondria supplies energy. For what? For the process to absorption to take place. So yes. As you can see, well, I think that you cannot see in the presentation, but here are a lot of finger-like structures, like surround the lumen of the proximal convoluted tubule, and those are called villi. And inside those villi are smaller, even smaller finger-like projections called microvilli. And as you might already know, in the intestines, the villi functions. The job of the villi is to reabsorb all the nutrients that the body needs. And in the proximal convoluted tubule, this happens the same. But this time is with all the glucose that was able to pass through the mesh of the glomerulus, and the glucose has to be reabsorbed by the ATP that the mitochondria supplies. And of course, water follows by osmosis, so the filtrate that will go on will to this point will contain urea, will not contain glucose because all the glucose was reabsorbed, will contain some water, will contain some salt ions, and yes, that's what happens in the proximal convoluted tubule. Proximal? Yes.
Glucocan.
Yes, glucocandy. Well, as you might see, this is like a type of, it's in the form of a U, and as you can see, well, the urea here passes from the proximal convoluted tubule up to the glucocandy.
It is divided in the descending limb and ascending.
Yes, and the descending limb is permeable to water but impermeable to salts, and the ascending limb is permeable to salts but impermeable to water. This means that in the descending limb only water can pass, and in the ascending limb only salts can pass through the membrane. So yeah, what happens is that when the filtrate at this point is like coming out from the glucocandy, a lot of water goes out, and in here a lot of salts come in. So what happens is that the surrounding environment of lower part of the leukocandy becomes very, very, very salty. So yes. Something very important to mention is that you cannot see it in the image, but in this area right here are a lot of arterioles called the peritubular arterioles, and those are the ones that carry all of the filtrate up to the bloodstream and back to the body, because those are like substances that you cannot dispose through urine, and their disposal is another type of mechanism that doesn't have to do with the kidney. So yes, this is what happens in the leukocandy. Yes. Do you have any questions up until here? No? Okay. And now we'll see the collecting duct. The collecting duct, before the collecting duct is this thing called the distal convoluted tubule, but what happens there is basically the same as the proximal convoluted tubule. So if you paid attention, you might already know what happens in there. So yes, the collecting duct. To this point, the substances, the filtrate that goes into the collecting duct is almost urine. But what happens is that the body has like this type of mechanism that it detects when you have not consumed enough water. So what happens is that the pituitary gland, which is an endocrine gland that you have up in here in your head, it releases a signal for the secretion of vasopressin, which is the antidiuretic hormone. This is how you call it, ADH, to be released. So normally the collecting duct is impermeable to water. This means that water cannot pass in or out the collecting duct. But when the body detects that you are not well hydrated, it will start the secretion of the antidiuretic hormone. So what this does is that in the collecting duct there are a lot of aquaporins that are made. And through these aquaporins, a lot of water is taken back from the filtrate, and the body keeps it in order for you to stay hydrated or to late up the process of dehydration. But this only happens if you haven't consumed enough water. So that's why you need to consume a lot of water.
Yes.
Yes. So therefore, if you consume a lot of water, your urine will be diluted. And if you do not consume enough water, the body will take back all the water that you have in order to not dehydrate, and that's why your urine appears like a more even darker color. And this is like a signal that your urine is very concentrated in urea, in salts, and all that stuff. And that's of course that because you haven't consumed enough water. Yes. Can you?
That's it, yes?
Yes, so that would be it for today's class.
The person practice, okay, in the practice you can find it in our website. You can make all the different activities. And in production also you can practice by doing all the activities.
Yes, you can find it on Blackboard.
Blackboard. Thank you for
your attention.